Welcome everyone. So today we are here to discuss about AP Pre-Calculus. And AP Pre-Calculus is recently launched and is an addition to the already existing subjects that also had AP Calculus. So we at Gnosis Learning provide the extra support that students require in order to furnish their skills, in order to score better in AP exams. And you can also visit this website in order to know about the other AP programs that we have. So AP Pre-Calculus is recently launched and it wasn't there before in the previous year. So that's why there are a lot of questions and a lot of doubts related to the same. So the main question starts with why AP Pre-Calculus? Why do we even need Pre-Calculus? Because we already had an AP Calculus subject. So basically, AP Pre-Calculus is a wonderful addition because it helps the student to explore everyday situations and phenomena using mathematical tools. So mathematics is required everywhere in our life, everywhere in every aspect, and in order to create better models and better inferences, we need mathematics for that. Even for better logical and analytical building, we need mathematics. Now, what pre-calculus does is pre-calculus contains topics which help the student to build their analytical and their logical skills in order to create a better base. All right. So once our logical building is going fine, it is going better, we are able to think much more better in a much more better manner. And hence, we need the very basics of maths first. Now, AP Pre-Calculus, it has some miscellaneous topics which are also extremely important for building a strong base for further college level and higher mathematical level questions. Also, for students who want to join any STEM majors or any science majors, AP Pre-Calculus gives a very strong base for the same. And although having a strong understanding of basic topics is extremely important to be able to observe, to be able to explore and build better mathematical meaning from dynamic systems. Now we need mathematics to build models for our future, for in better institutions, validate function models using topics like transformation of functions and regressions. We will be studying about what we mean by regressions, be that linear regression or regressions inside functions. Students also learn to select mathematical models, model-based characteristics of bivariate datasets. So any dataset that we will be using will be a bivariate dataset. And we will be studying about the characteristics of covarying quantities and their relative rates of change. We will be studying about topics related to rate of change, be that polynomial function rate of change or linear rate of change. We will be studying about identifying, interpreting, and applying the information that we are finding from a function model for a given context or for a data set that we have. AP Pre-Calculus is also a very nice addition for students with non-STEM majors, for students who do not want to deep dive into calculus in order to get into a course which only requires the basic minimal mathematics. Now, what are students going to experience in pre-calculus? There are 4 basic things that students are going to go through. So, the primary thing that students will go through is the modeling of real world data, because we are putting in we are using the real world data. We are not doing anything mythical. So, we are using the real world data in order to create better inferences for institutions. Students, they are going to develop symbolic manipulation skills, which will be needed for future mathematics courses. So, as said earlier, this AP Pre-Calculus is going to be a very nice base for AP Calculus or for AP Statistics or for future college level mathematics. And students are also going to learn single mathematical object, which can have analytical representations and different analytical representations that reveal different attributes of the mathematical object. Another thing is harnessing a dynamic world. Now, what do we mean by harnessing a dynamic world? Students are going to engage in function building. We are not just going to solve questions. We will be engaging in function building that does not reflect a static view of things but embodies how things change. We will be studying about how transformations take place in functions. All right, so we are not just we will not be focusing on one value of the variable. We are going to see how a function changes when the value of a variable changes. We are going to see that change in the graph. And this study of function and their graph as embodying the dynamic covariation of quantities prepares students to understand an ever-changing world. And hence, we are using the word of harnessing a dynamic world. Another thing that we have is we are exploring multiple representations. Now, students will examine functions through multiple representations. We are not just using one topic in order to use functions. Now, basically, what are functions? We have been using this term again and again. So, functions is just a mathematical relation that maps a set of input values to a set of output values. In layman's term, we are giving in some input and something is happening inside, and then we are getting an output. So we have an input set, we are giving some input values, and after that we are getting some output values. What is happening in between is the work and is the duty of a function. So it is going from set A to set B after getting through some function transformations. Now, one thing that we know is that a function can have multiple outputs for a single input, but it cannot have multiple inputs for the same output. There cannot be two inputs for a same output. That will not be a function. So in order to have a function, we need to have multiple outputs for a single input. We understand how we are going to use the real world data and how we are going to use the actual thing. We are going to see how the dynamic world works, how dynamic the mathematical world is, because it is not static. We are not just focused on one value. We are seeing how things are going to change, and hence we are harnessing a dynamic world. We are going to see multiple representations of the same function, and at last we have our mastering of symbolic manipulation. So we already discussed about that, how students are going to develop rigorous symbolic manipulation skills which are required for future mathematics courses. After applying all of the tools that we have studied in this course, and we are going to apply that into real world modeling situations so that we can have better inferences about institutions and about how things go about and how they work. And students are eventually going to gain a deeper understanding of the nature and the behavior of each function type, how each function works, and what is happening in between of this function. All right. So we have the basic course framework here. In the first unit, we will be studying about the polynomial and rational functions. So we already learned about what functions are. And following that, we have our polynomial functions, and in those polynomial functions we might have linear functions, our quadratic and cubic functions, etc. In the second unit, we have our exponential and logarithmic functions. Third has trigonometric and Polo functions. Eventually we have functions which involve parameters, vectors, and matrices. So all of these basic topics, they are a base for your AP calculus. So learning all of this is very important before we learn AP calculus and more complex topics that are there in AP calculus. So these topics are very basic. And if the basics of mathematics are not clear, then moving forward to any complex topic is not viable. So learning these topics before and creating a strong base for yourself is the best way to go about it. And the best way to make something strong, make a strong base, is to practice and with a proper plan. And here is where we are going to help you to create a proper plan and the practice that we are going to put in. Now let us dive deep in and let us see what are the prior knowledge that will be required in order to follow this AP pre-calculus form that we have. So we need to know what linear functions are. I already explained what functions are. We also need to know what linear functions are. There must be proficiency in polynomial addition and multiplication. One must know how the polynomial functions go about and how they work, and how we can add the functions. For example, if there is an x square and you can only add it with another x square variable, only this can work, and how multiplications happen inside a polynomial function. We need to know how to factor quadratic trinomials. We need to learn how we can create factors of a quadratic trinomial or of a polynomial function. We need to learn how to use the quadratic formula that we have, that is the minus b plus minus of that. Following that, the quadratic formula and how the quadratic formula is used, because learning this is only going to help us further. So we need to know how we solve the right triangle problems using trigonometry. We're talking about the Pythagoras theorem here. Now, learning how the Pythagoras theorem works about the hypotenuse, the base, and the perpendicular that we have, we need to learn how to apply that into questions, and that should be something that you're already done with. Further, we need to have a proficiency in solving the linear and quadratic equations along with the inequalities. So one must know how to solve a linear, linear equation, along with learning how to deal with inequalities. Inequalities is equally important as solving a simple equation that we have. Alongside that, we need algebraic manipulation of linear equations and expressions. With that, we need to learn how to solve system of equation and in 2 and 3 variable. So until here, we only have one variable, but we already need to know how to solve system of equations. Say we have 3 equations with 3 variables each, and learning what will be the value of each variable therein. Alongside that, simple familiarity with exponential functions, so that we can go about exponential and logarithmic functions. So you should know what exponential functions are. Certain rules of exponential functions go well. Rules for exponents, how exponents go about, and what are the rules that we require. What happens if I give you this? What will be the value of this? One should know the rules for exponents. Then we need familiarity with radicals, how square roots and cube roots work, how you can find the square root of a function, a square of a function, and the square root of a function. How you can learn the cube of a function, and how you can learn the cube root of a function. Alongside that, a familiarity with complex numbers, the iota and the minus of negative inside a root. Just a simple familiarity with the topic of complex numbers is good to go. That's how we go about it. And once we have all of this prior knowledge and skill, you do not have to be a master in this, but if we have this thing of strong basics of these things that you must have learned until now, we will be able to apply these topics over here, so as to make a strong base in mathematics, which will further help us in AP Calculus and college level mathematics. Further, there are certain conventions, some common language usage that we have, and that we need to know, which is going to be uniform throughout the course. Some example, the area of a triangle means the area in the interior of a triangle, which is very basic. For example, if we have a triangle and we need to know what the area of a triangle is, so by that we mean the area which is inside of the 3 sides. Again, when the framework refers to a modeling of a data set, it is referring to a bivariate data set. We have already discussed this before, that whenever we are modeling a data set, whenever we are relating or referring to a modeling of a data set, we are talking about a bivariate data set. When the framework refers to modeling a context or a phenomenon, it is referring to the 2 aspects of the context or phenomenon. We are talking about the 2 aspects. We are not talking about anything other than that. So When the framework refers to sine, cosine, and so on of an angle, it is referring to the sine, cosine of the measure of the angle. So whenever we are talking about sine theta, we are talking about the value that is going to be there inside this theta value and what is the measure of this theta angle. And that's why we are talking about, say, the value of theta over here is 30. So we are talking about the value of the measure of the angle. We are talking about sine of 30. We're not talking about sine 30. Sine, what will be the value of sine on the angle 30? Now there are some skills which are associated with 3 mathematical practices. What do we mean by mathematical practices? We have our procedural and symbolic fluency. We have our multiple representations and communication and reasoning. While many different skills can be applied to one content of topic, the framework supply skills focus on recommendations for each topic to help assure skill distribution throughout the course, so that the student can learn all of the 8 skills that are present here, and hence that's how the AP syllabus has been built, so that all of the skills are inculcated inside the syllabus and inculcated in the student. So we have our procedural and symbolic fluency, wherein we have our algebraically manipulate functions, how we can algebraically manipulate functions, how we can change functions and their way, how we can solve functions and expressions. Then we have how we can translate mathematical information between representations. Mathematical information translation basically means transformations inside of functions. Then we have communicate with precise language and provide rationals and conclusions. Now, if we are making a model and if we are using mathematics, then we need some inference from that. There is no point if we do not get any conclusion or any inference between those two, after doing certain equations or after doing certain mathematics. We need to have conclusions and inferences. What helps when we do this? How does that help? What a skill does it give? It describes the characteristics of a function with varying levels of precision. We apply numerical results in a given mathematical equation or in an applied context, and we support conclusions. Further, we will be moving at course in detail. So the primary thing that we have, before that, let us talk about the exam pattern. Now, we at Gnosis Learning, we help you solve and score better, both in multiple choice and free response questions. So this is like a 360 learning platform, wherein you will be able to solve multiple choice questions and the free response questions both at the same time. So we have 36 questions of multiple choice of part A, that is graphing calculator will not be permitted. So, and 12 questions wherein the graphing calculator will be required, and accordingly we have our weightage. Then we have our free response questions, wherein we will have 4 questions in total and 60 minutes for those 4 questions. So the pre-calculus exam, it basically assesses the student understanding of the mathematical practices, and that's why we are taking in the real world data and manipulating that to get inferences. The exam will be 3 hours long and includes 48 multiple choice questions and 6 free response questions. Again, let us go in detail in the course. So the first unit consists of polynomial and rational functions. The polynomial and rational function, what do we mean by a function initially? So we know what a function is. A function is a relation that maps the set of the input to the output. So we're given some input and we get some output after the function work has been done. We will be learning about the domain of a function, the range of a function, how there are variables, and the variables, there are types of variables we have. We have independent and we have dependent variables. Again, we have the function rule, we have increasing or decreasing functions, and the graph of a function, say how the graph goes up. The graph of a function may be concave up, it may be concave down. And similarly, we are talking about the rate of change of a function. Now, the rate of change of a function here, it might be in linear, and the rate of change in a function may be in a function that is linear, quadratic, or even polynomial. So rate of change quantify how two quantities varies together. So we have two quantities together, and rate of change helps us to know how both of these quantities, they are changing together in a similar pattern. Now we are talking about polynomial functions and rate of change. Similarly, that is pretty similar. We are now talking about polynomial functions and complex zeros. Now, what is a complex number? We know that initially there cannot be a negative root. There cannot be a negative value inside of a root. To solve that issue, we have complex numbers. Okay, a complex number is basically an iota. That is, the value of I over there is negative of a root, -1 inside of a root. We will be talking about the real roots of a polynomial functions and the non-real zero of a polynomial. So we already know about how to find the zeros of a polynomial or the roots of a polynomial function. But all of those real numbers were real numbers. We will be now talking about the non-real roots of a polynomial function. Some knowledge that we must have is we will be studying about the even function and the odd functions inside of the graphically symmetric functions. Then we have polynomial functions and their end behavior. We will be learning about the end behavior of a polynomial function and of a rational function. Then we will be studying about the rational functions and the zeros that we have. Now, what do we mean by that? A rational function is basically an analytical representation as a quotient of two polynomial functions, and it gives us a measure of the relative size of the polynomial function. And that relative size of the polynomial function is given to us in the numerator compared to the polynomial function in the denominator for each value in the rational function's domain. Similarly, the end behavior of a rational function will be affected, of course, and most of the polynomial with the greater degree. Why? Because the values will dominate the value of the rational function for the input of the larger magnitude. We also know that if the polynomial in the numerator dominates the polynomial in the denominator for any input of larger magnitude, then the quotient of that leading term is a non-constant polynomial. Also, we must know that if neither the polynomial in a rational function dominates or the input value for the larger magnitude, then the quotient of the leading terms is a constant. Else, it is a non-constant. We will be learning about the rational functions and the vertical asymptotes. As you can see, until here, we are done. And learning about the rational functions and the wholes and the equivalent representation of polynomial and rational expressions. We will be learning how to rewrite polynomial and rational expressions in equivalent forms. We will be determining the quotient of two polynomials using long division. So, how to deal with polynomials and division of polynomials? The best way to do so is to do so with long division. We will be rewriting the repeated product of binomials using the binomial theorem that we are going to study. With that, we have transformation of functions, as we have been talking about. So transformation of functions is it is to construct a function that is an additive and the multiplicative transformation of another function. So in transformation of functions, there are basically two operations that we can perform, that is plus and a multiplication. Addition and multiplication are the basic two operations that we perform inside transformation of a function. Following that, we have our function model construction and application. Then we have in the second unit, we have exponential and logarithmic functions. Again, very important topic for very basic mathematics that we have. So the first thing we have is change in arithmetic and geometric sequences. So we have our AP and GP over here. Our arithmetic progressions, our geometric progressions, and how and what sequences and series are. And let us just start with talking about what a sequence is. So a sequence, it is basically a function from a whole number to the real numbers. Consequently, we can know that the graph of a sequence consists of discrete points instead of a curve. So in the graph of an AP or a GP, there are going to be discrete points. There are going to be random points, and there will be no curve. There is no curve. There are random points inside of a GP or a AP graph. So just by listening to the word of sequence, we know that there must be successive terms that are there in an arithmetic sequence, and we have a common difference, and we have a constant rate of change. So we have a first term, we have a difference between the two terms. So we have terms, say A1, say A2. We have constant terms which go till AN, and N can be the number of terms that are present there. So A determines the first term, A1 is equals to A, and D is the difference between the two terms. That is, A will be A2 minus A1. That is D. We will be talking about sum of n terms, the difference of n terms. And similarly, successive terms in a geometric sequence, they have a common ratio or a constant proportional change. That is the major difference between an AP and a GP. AP only has the difference between two terms, whereas in a GP there is a common ratio between the two terms. Then after sequences and series, we have linear and exponential functions. Now, what are linear functions? Linear functions are of the let me write here. Linear functions are of the type y is equals to mx plus c. Now, this is also the equation of a line, and that is exactly what we are proving here, that linear function is basically a line, and the change in that linear function is what we have to associate ourselves with. Then we have our exponential functions. Now, exponential functions are of the form say a b e raised to the power something. Okay, so that's what we have here. The variables must be same. So something raised to the power x is what we talk about in an exponential function. We will be studying about how the exponential function changes when the value of the variable changes and the other terms change as well. We will be describing the similarities and the differences that are there between linear and exponential functions. Then we will be diving deep inside of exponential functions, and we are going to identify the key characteristics. So we will be studying about the general form of an exponential function, and how the output varies, and how, because of the output values, we will be studying about the additive transformation of a function, and the exponential function in a general form. The second thing that comes about exponential functions is the exponential function manipulation. What do we mean by manipulation? That we are rewriting the exponential expression in an equivalent form. So how we can write that same exponential equation in a similar manner or in a different form, but actually the value of both of these functions will be the same. We will also be studying about the negative exponent property. We will be studying about how the value of an exponential expression changes and how the natural numbers and everything works about there. Then we have exponential function context and data modeling, wherein we are going to construct a model for situations involving proportional output values over equal length input value intervals. Moving forward to composition of functions we have here. Composition of functions that we have here, wherein we are going to evaluate the composition of two or more functions for some given values that we have. We will be talking about composite functions and the composition of functions that are commutative, maybe not commutative, the properties that are there inside of that. We will be constructing a representation of the composition of two or more functions. We are going to rewrite a function as a composite or maybe of two or maybe more functions. Then we have inverse functions. Now, what do we mean by inverse functions, and how we go about solving inverse of exponential functions and of normal functions? We will be determining the input and output pairs of inverse of a function. We will be determining the inverse of a function of an invertible domain. After, of course, we learn about what a domain of a function is. Further, we move on to logarithmic expressions. Now, the logarithmic expression is basically, it represents the value of the base b and must be exponentially raised to in order to obtain the value of c. In a logarithmic function, we have log, we have a base b, and we have some value c. Once we solve this entire expression, we get some value, which is the conclusion of a logarithmic function. The values of some logarithmic expressions are readily accessible. We already have the solved function, solved value of log 1, 2, 3, 4, 6, even till 10. But there are certain values that need to be solved and which are not accessible readily. Also, we need to know that on a logarithmic scale, each unit represents a multiplicative change of the base of the logarithm. So the value of the base, that the b over here, is very important. Basically, we are using a logarithmic base of 10 when nothing else is specified. So we take the base to be 10 and hence solve accordingly. Then, after studying about inverse of normal functions, we have inverse of exponential functions, wherein we need to learn the general form of a logarithmic function alongside the base, and then also know the graph of the logarithmic function and what the reflection of the graph of the exponential function will be. So we are basically constructing representations of the inverse of an exponential function with an initial value of 1. Then we will be talking about the key features of logarithmic functions, the domain of a logarithmic function, and the inverses, say the increasing or the decreasing manner of the graph of a logarithmic expression, and so on. Again comes the similar pattern of logarithmic function manipulation. Similarly, how we did the exponential function manipulation, we are changing the way we write a certain equation into some other way wherein both of their value will be same. We will be talking about the inequalities next. So until now, we are only talking about how to find the value, how to change the way of equation has been written. But now we will be talking about the inequalities, wherein we will be solving the exponential and the logarithmic equations, and we are going to construct the inverse function for these exponential and logarithmic functions using inequalities. Now, this next thing that we have is the logarithmic function context and data modeling, which is a very interesting topic. Here comes in the actual inferencing, actual thing that we are going to get, because we already have the data, we know how to manipulate the data, and once we learn this, we can learn how to create a data model. Once we solve these two basic units, we have a very important topic of trigonometry in the third unit. Now, trigonometry is the base of AP calculus. we need to know trigonometry in a very nice manner, in a very detailed manner, in order to solve the calculus part. The first thing that we are going to learn about in trigonometry is the periodic phenomena, that is the periodic relationship. And a periodic relationship, it can be identified between two aspects. As the input value increase, the output value demonstrate a repeating pattern over successive equal length intervals. So what we are doing here, we are basically constructing graphs of periodic relationships based on verbal representations. Then we are going to describe the key characteristics of a periodic function based on a verbal representation. We will be studying about sine, cosine, and tangent values, their function values, and how we can manipulate these values. Then, after learning the representation of the sine, cosine, and tangent, we will be learning how their graph works. So we will be given an angle of measure in standard position, and then we have to use that value in order to create a sine or a cosine graph. Then we have transformations of the trigonometric identities. We will be learning about the tangent function in deep. We will be tangent value is basically tan theta is equals to sine theta divided by the cos theta, wherein the value of theta remains uniform, and that's how we get the tangent value of a function. We will be learning about the tangent function behavior at different input values, and how the different input values give us different output values on the graph and even on the equation side. So the tangent function, it increases and its graph changes from concave down to concave up between consecutive asymptotes. So we will also be learning about how graphs work and how tan theta is being how tan theta works accordingly. Similarly, we will be learning about the inverse of trigonometric functions, since we have already learned about the normal trigonometric functions. And then we go about in polar functions, we go about in range of change in polar functions. And similarly, the final unit that we have is the functions involving parameters, vectors, and matrices. So what are parametric functions? A parametric function is basically the set of all ordered pairs of two real numbers, and it consists of two parametric equations. Basically, parametric function means to evaluate one function with respect to some other function that we already have. So we are solving, say, sine y with respect to sine x. Whenever we are solving a function with respect to some already given function, is known as the parametric functions. Then we will be talking about the parametrically defined circles and lines, how the conic sections work, and the parabola, the ellipse, the hyperbola. All of these conic section values are going to get in, and we will be learning about the equations of the same. Finally, we will be learning about vectors and matrices. Now, vectors are basically, so a vector, it is basically a directed line segment. So what do we mean by a vector? So it basically shows you the direction in which a particle may be moving. It gives us the space, the area that it has moved, and the direction that it is moving in. And that's how we talk about vectors. Following that, we have a very important topic of matrices. A matrix is basically a huge bracket which consists of terms inside of it. If you know about computer science, you can think of it as an array of certain size. And two matrices, how they can be multiplied, how they can be added, reduced, talking about the inverse of matrices. That's all we are going to do over here. Thank you, everyone.